Hello and welcome to our video on examples of topological spaces. In this video, we'll be discussing what topological spaces are and looking at some examples to help you understand the concept better. Let us take a look at some examples of topological spaces. First example is Euclidean space. Euclidean space is the most familiar example of a topological space. It is the space of points in 2 or 3 dimensions that we are all familiar with from our everyday life. In this space, the open sets are defined as balls, which are sets of points that are within a certain distance of a given point. This is a 2-dimensional Euclidean plane. The 2-dimensional Euclidean plane is a mathematical concept that represents a flat surface that extends infinitely in 2 directions, typically referred to as the x-axis and y-axis. The plane is often denoted as r², where r represents the set of real numbers. The 3-dimensional Euclidean space is a mathematical concept that represents a 3-dimensional coordinate system that extends infinitely in all directions. It is often denoted as r³, where r represents the set of real numbers. In this space, any point can be identified by an ordered triple of numbers x, y, z called coordinates, where x represents the horizontal distance from the origin, y represents the vertical distance, and z represents the distance in the 3rd dimension, usually referred to as depth. The origin is a point that serves as the reference point, typically denoted as a 0, 0, 0. Similar to the 2-dimensional Euclidean plane, points in the 3-dimensional Euclidean space can be connected to 4 lines and planes, and multiple planes can intersect at a single point or be parallel, never meeting. The Euclidean distance metric can also be used to calculate the distance between any 2 points in 3-dimensional space. Our next example is discrete space. The discrete space is another example of a topological space. In this space, every subset is open, which means that every point is isolated and not close to any other point. You can see the shape of a circle in discrete space X. The circle becomes deformed by the resolution, being hard to decide whether it represents a circle. Next example is the Sierpinski space. The Sierpinski space is a topological space that has only 2 points, which we'll call 0 and 1. The open sets in this space are defined as follows. The empty set is open, the set 1 is open, and the set 0, 1 is open. Look at the shape, which represents Sierpinski space. Next example is the torus. The torus is a topological space that can be visualized as a donut shape. It has a unique topology that is different from Euclidean space. In this space, the open sets are defined by taking a subset of the torus and inflating it slightly so that it contains all points that are close to the subset. Look at the shape, which is the torus. It is a surface of revolution generated by revolving a circle in 3-dimensional space about an axis that is coplanar with the circle. Our next example is the spherical space. The spherical space is a topological space that can be visualized as the surface of a sphere. In this space, the open sets are defined as sets that can be obtained by taking a subset of the sphere and inflating it slightly so that it contains all points that are close to the subset. You can see the map of the world, which represents spherical space. That concludes our video on examples of topological spaces. We hope this video has helped you understand what topological spaces are and how they can be used to define the concept of closeness between sets of points. Thanks for watching. If you enjoyed this video, don't forget to hit that like button and subscribe to our channel for more great content. And if you have any comments, suggestions, or questions, please let us know in the comments below. We love hearing from you. If you want to see more videos like this, check out our playlists. Thanks again for watching, and we'll see you in the next video.